Hey everyone, welcome back to my channel EduVibe. In today's lesson, we'll start with the inner topic of the atomic physics, which is the matter and the particle classification. What is that topic? So in this topic, we'll start doing with the antiparticles. We are start moving to the particles, from the particles to the antiparticles. Like we had discussed in the previous lessons that all the particles have their antiparticles. Like electron, if it has the negative charge in the particle, when if there's antiparticle, we have a positive charge of that. So that's the thing. If the electron, if the negative charge, we have to say that this is the electron. But in the positive charge, we create it as a positron. Same thing we do with the neutron, proton, and some other particles, which they have their antiparticles now. So we discuss those things from today's lesson uh, till the end of this unit now. So let's start with this. So firstly, the discovery of the antimatter. So if we have a matter, we have an antimatter too. From there, we can start dealing with the antiparticles. So, in 1932, American physicist took a photo of the cloud chamber that shows the existence of the particle that had not yet been seen. So, this cloud chamber topic we already discussed in the previous lesson. If you don't see that, you have to watch this lesson first because this is related to that theory. So, the cloud chamber picture then taken by the American physicist in 1932, they seen that there is some resistance of a particle which is not have been seen yet. There's a new for that. He had calculated the charge to mass ratio of this particle because we know that if we want to do some radius of particle we want in the from the chambers, we can do the charge to mass ratio. Okay, we all that discussed in the previous lesson. You can watch this lesson. So they calculate that thing charge to mass ratio of that particle. It has same as the electron. So you get the same as the electron. However, based on direction of the curvature, the path of particle and the magnetic field, he knew it had to be positively charged, not negatively charged. So they doing something, they will get some direction of the curvature, they will get some path of the particle, they calculate some magnetic field, and after that they will say that he knew that it had to be positively charged. But you know that if there is the same if they get the same as the electron thing, so it must be we want a negative charge for that. But they get the positively charged instead of the negatively charged. Then he was the first to discover the antimatter. So they start with the matter thing, and from here they get the particle which is the electron. So in this case, he discovered the positron, which I discussed over there. The electron has antiparticle positron, which is positively charged. So you get a positive charge for the electron, which is the positron. From he discovered that, and this is an antiparticle to the electron. One of the interesting properties of the particle and its antiparticle is when they collide with one another. When we collide this one with negative and positive electrons are combined with both, we know that this is called the annihilation. So while the particles are effectively destroyed, keep in mind that energy they carried prior to the collision cannot just magically disappear. They call the conservation of mass of energy. So in this topic, we involve in the mass of conservation of energy to find the because they collide, they will destroy, but the energy can be released or absorbed in that case. So we are going to say it's a mass energy thing. We involve that thing in this too. For a particle, antiparticle annihilation, energy released in the form of two photons, which can travel in the opposite directions. Uh, so when they collide, the energy is released, and they have a two photons. They go in the opposite directions of this, which then is the conservation of momentum. So we also involve the conservation of momentum in this. So these two laws are can be used, and that picture he take from a cloud chamber is lined up like this. This picture from where they get the positively charged electron, it's a positron. So to calculate these type of sums, that when the energy is released, we have something. So from that something, they will collide, they will destroy, they will left with some rest mass and energy. So that mass we call that this is all the rest mass and the energy they released. When examining the subatomic particles, we need to consider something called the rest mass energy, which is a very important thing when we calculate the sums in this, when we calculate calculations in this. So the rest mass of energy of particle is the energy that is stored inside a particle at rest, similarly the result of its mass. So it is that energy which is stored in a particle already, and it simply is the result of its mass. It is simply the mass of that thing. The rest mass of energy of a subatomic particle calculated using Einstein's mass energy equivalence formula. We are again doing that formula, which is the Einstein's formula, and you will also see your data sheet. The rest mass for some particles is given to you. You have some rest mass given to you. We discuss this more that thing in the later on lessons. In problems where the kinetic energy of particles involved in the reaction are significant, you must consider the both kinetic energy and the rest mass energy when applying the law of conservation of energy. So when we're doing those sum, I will discuss that thing. I will discuss line to you. So let's straight to the sums to discuss that thing at which is going on that. So because when you get that antiparticle and particle, the both thing like this, they have mentioned that there is a proton and electron animation. That sums neither both things. If they're not cut out, we need the both things. So we have to calculate the energy of high energy photon produced from a proton electron annihilation. We assume the kinetic energy of particle is negligible. So how can you start with that? So after the collision, we will get a two photons as we mentioned earlier. So there is a collision occurring and we get the two photons in here. So there's a negative electron, there's a positive electron. They collide with that and we get a two photons in this. So we have some initial thing, we have some final thing. So there's an initial energy and the final energy is the different in both cases. So energy in initial is equal to the final energy. Initially, we have a kinetic energy of the electron and we have a kinetic energy of the positive electron because both are moving when they collide. And also we have the both of them, the rest masses in that involved. Initially, both rest masses are also there. So the energy of the rest mass, you have to write the Rm electron negative plus Rm electron positive. And when they collide, the final thing is that we get the two photons and we get the two photons energy. The starting in the starting we have that electrokinetic energy goes to zero and positive energy goes to zero. Only the rest masses are the thing which is involved in that at that time. So we have to only involve these two things, and now we have to open these two things. So we have energy of this and we have energy of that. So there you can use this formula when you use the kinetic energy is equal to delta mv square. We already discussed copy mass defined kinetic energy thing when we relate that those things. So we can use this formula. So there is a mass defect which is the mass of the electron negative and c square plus we have another thing c square is equal to the energy of the two photons. That thing we have to decide that the mass of the electron negative is equal to the mass of the electron positive because both are the electrons and both masses are the same as that in this we discussed. They're the same thing as the electron. So the negative electron and positive electron both have the same masses and both should be equal to the mass of the big M electron, which is the mass of the electron. So these are the two, and we plus them, we get this c square is equal to the 2 energy of the photon. So the energy of the photon, when you cut these two over there, you get the big M, which is the mass of the electron, c square. You can put the things now. So the mass of the electron is 9.11 into 10 raised to minus 31 kgs and c square 3.0 10 raised to power 8 meter per second square. So when you calculate this over there, you get 8.20 into 10 raised to power minus 14 joules. And this is your energy of the photon you have to calculate. So the main thing is that you have to know that you have to compare the rest masses and the two electron of the that photons have been two things. So we have to compare these both things. This is a simple kind of question. Sometimes you get some complex one when the no anything needs not be cancelled. Here they mention that kinetic energy is negligible, which means we can't calculate the energy of the initial things. So that's why we take both as the zero because they're negligible. If they not mentioned they are negligible, we have to take the all things. We have to do all the steps half mv square like this. All the things we have to do in this, like we do in this question. So the question says the proton and the antiproton. So we have now protons are approaching each other with the speeds of 5.8 into 10 raised to 7 meter per second. When they collide, they ignited each other with the two gamma photons are emitted. Gamma means the photon. Tell me the minimum wavelength possible of the gamma photons. You may ignore the realistic effects. So we have to find the wavelength in this, and we have a speed given which they're approaching. So again, we do the same thing, which is EI is equal to EF. The final initial energy is equal to final energy. So we have this thing, we have a 2 gamma, and we have a proton, and we have an antiproton, which are approaching with the same speed. So initially, we have the kinetic energy of the positive proton plus kinetic energy of the negative proton plus rest mass of the positive proton plus the rest mass of the negative proton, which will equal to the energy of the two protons. So nothing can be cancelled in this stage. The energy of positive proton and energy of negative proton can be cancelled in that case because they did not say that energy is negligible. We have to take that. So the half m vp plus c square, this is half, plus half mp minus v square, plus we take it as the this thing, the mass energy equivalence. We get this. From here you can know that this thing is equal to this thing, which is equal to the mass of the proton. You get the mass of the proton in this. And also you can multiply this by 2 to get the half cancel out from both. So when we multiply by 2, you get the this thing plus this plus this plus this and that 2 from this. Then now you will get this plus the 2mp square, which is equal to the 2 protons. Now this proton is equal to the mpv square plus 2 mpv ski square upon 2. So now you have to have all the things. The mass of proton is 1.67 into 10 raised to minus 27 kgs. The velocity is given is 5.8 into 10 raised to plus 7 meter per second, plus 2 times again the mass of the proton, which is this given in data sheet, and c square, which is 3.0 10 raised to power 8 meter per second scale of that. The whole thing is divided by the 2. Get your proton, energy of proton is 1.5310 into 10 raised to power minus 10 joules. But you want a wavelength, so you know this is equal to the hc upon wavelength, and wavelength is equal to hc upon the energy of the proton. So this thing, so 6.63 into 10 raised to minus 34 joules per second into 3.0 10 raised to power 8 meter per second. This has to be divided by the energy of the proton, which is 1.5310 into 10 raised to power minus 10 joules. When you calculate this, you get 1.30 into 10 raised to power minus 15 meters. And this is your wavelength. That's how you can find the wavelength, and make sure when it is non-negligible, so you can't cut these two things. You have to be, these things have to be there, and you have to calculate all the things like this and get your wavelength. This is a summary of some the anti-particles or particles. Electron has the proton, proton has the antiproton, neutron has the anti-neutron, neutrino has the anti-neutrino, and they are the symbols of all the things. So you have to be careful about these things. So that's all for this lesson, and we start the antiparticles thing and we involve that thing in the next lessons too, and we get the whole things now. So language I do EduVibe, learn smart not harder. Please like and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till let's create it with EduVibe.